Did you know how the steel used in your everyday life is produced? From the car you drive to the knife you use to cut your apples and the heavy military machinery produced, steel is an essential material in our daily lives. It's not just a matter of melting down iron and calling it a day. No, it's a complex, multi-layered process that's as fascinating as it is vital. Steel production is a fascinating multi-step process. Stay tuned to delve into the details. It all begins with the raw material iron ore. You might be wondering, what exactly is iron ore? Well, it's a rock or mineral from which iron can be profitably extracted. It's the primary raw material used in the production of steel, and it's found in abundance all over the world, from Australia to Brazil and from China to Russia. Now, how do we get the iron out of this ore? The process is called mining. Massive machines dig into the earth, extracting the ore. This isn't a delicate operation. It's a feat of brute strength, a testament to human ingenuity and determination. Once the iron ore is out of the ground, it's not yet ready to be used. It's transported to a processing plant where it's crushed into a fine powder and separated from other minerals. This resulting high-grade iron ore is then ready for the next step in the steel production process. Once extracted, iron ore is ready to undergo the transformation into steel. The first stage of steel production involves converting iron ore into pig iron. This isn't just a simple matter of melting down iron ore and pouring it into a mold. Oh no, this process is a bit more complex and fascinating. Imagine a towering structure known as a blast furnace. This is where the magic happens. Iron ore, which is primarily iron oxide, enters this furnace alongside two crucial companions, coke and limestone. Coke, a high-carbon fuel made from coal, serves as a reducing agent. Its role? To strip away the oxygen from the iron oxide, leaving behind pure iron. But this isn't an easy task. It's like trying to convince a stubborn friend to change their mind. To make this happen, we need a high temperature, about 1,800 degrees Celsius. And that's precisely where coke shines, by burning in the furnace and creating the extreme heat needed. Now let's not forget about limestone. This unsung hero acts as a flux, a sort of mediator in this hot and heavy process. As the furnace works its magic, the limestone melts, combining with impurities from the iron ore to form slag. This slag, lighter than molten iron, floats to the top, making it easy to remove. What's left behind is a molten form of iron known as pig iron. But why call it pig iron, you ask? The name has a bit of history. Back in the day when the molten iron was poured out into sand molds, the layout looked a bit like piglets suckling a sow, hence the name pig iron. And there you have it, the creation of pig iron, a raw material that's not quite steel, but a crucial stepping stone in the process. It's rough and brittle, not quite useful in its current state. But fear not, this is just the beginning of its journey. With pig iron in hand, we're ready to move on to the next stage. Now we transition from pig iron to steel. This is where the magic truly happens, where we transform an unrefined material into one of humanity's most versatile resources. Let's start with the basic oxygen steelmaking method, often shortened to BOS. Picture this: a gigantic vessel known as a converter is tilted to one side, and in goes our pig iron, molten and eager for transformation. Now, here's where the oxygen in basic oxygen steelmaking comes into play. A water-cooled pipe called a lance is lowered from above, and a powerful blast of pure oxygen is introduced into the molten pig iron. This oxygen reacts with the impurities in the pig iron, particularly the carbon, forming carbon monoxide and carbon dioxide gases, which escape into the atmosphere. This process reduces the carbon content and transforms our pig iron into steel. The whole process is as mesmerizing as it is efficient, taking a mere 40 minutes to complete. But what if I told you there's another method? Enter the electric arc furnace, or EAF. This method is especially popular for recycling scrap steel. The EAF method uses high-voltage electric arcs to melt the steel. Instead of oxygen, this process uses electrical energy, generated by 3 graphite electrodes. These electrodes create arcs of electricity that melt the scrap steel. It's a spectacle of sparks and molten metal, a testament to human ingenuity. Both methods, BOS and EAF, serve the same purpose: to reduce the carbon content of pig iron or scrap steel and transform it into high-quality steel. Both processes manipulate the elements either by introducing oxygen or by generating electricity to create a material that has shaped the course of human history. And voila, we have steel. But the process doesn't end here. Our journey from iron ore to steel is far from over. Let's dive deeper into the final touches that turn this raw steel into the shiny, durable material we see in our everyday lives. The steel is now ready for the finishing touches. Having come a long way from its humble beginnings as iron ore, it's now time for our steel to take on its final form and properties. First off, we have casting. This is where the molten steel is poured into molds, also known as casts, to take on a specific shape. You see, steel is a bit like a Hollywood star. It needs a good casting director to help it find its role. Whether it's destined to become a car part, a girder for a skyscraper, or a humble spoon, this is where it all begins. Next up, we have the rolling process. This is where the cast steel is passed through one or more pairs of rolls to reduce the thickness and to make the thickness uniform. It's kind of like a steel spa day, a bit of a squeeze here, a bit of pressure there, and voila! Our steel is looking leaner and more uniform. And last but certainly not least, we have the coating process. This is where the steel is coated with a layer of zinc to prevent it from rusting. It's a bit like applying a good sunscreen before a day at the beach. It protects the steel from the harsh elements. Zinc, in this case, is our steel's best friend, gifting it with a shiny, rust-free existence. But of course, these are just a few of the many processes that can be applied to our steel. Depending on its final purpose, it might undergo heat treatments to increase its hardness, or it could be worked with hammers and presses to further refine its shape. Each step in this journey, from casting to rolling to coating, is carefully controlled and monitored to ensure the highest quality. It's a testament to the wonder of engineering that we can take something as simple as iron ore and transform it into a material with such versatility and strength. Finally, the steel is ready to be used in a myriad of applications, from construction to transportation. From the tallest skyscrapers to the cars we drive, steel is truly the backbone of our modern world. Let's take a moment to recap the fascinating journey from iron ore to steel. Our journey begins with the extraction of iron ore, a rock or mineral from which metallic iron can be economically extracted. Iron ores are rich in iron oxides and vary in color from dark gray, bright yellow, or deep purple to rusty red. Once the iron ore is dug up from the earth, it's shipped off to the smelter. The iron ore then undergoes a series of chemical reactions in a process known as smelting, which results in the creation of pig iron. This is a crucial step, as it helps to remove impurities such as sulfur and phosphorus from the iron. The end product, pig iron, is a brittle material that needs to be further refined before it can be used. Next, we embark on the steel-making process. Now this is where the magic happens. The pig iron is melted down in a furnace and then subjected to a process called basic oxygen steelmaking. Oxygen is blown through the molten pig iron, reducing the carbon content and transforming it into steel. This process is vital because it's here that the steel gains its strength and flexibility. But the journey isn't over yet. The steel now needs to be shaped and finished. The molten steel is poured into molds and left to cool and harden. Once it's hardened, it's sent through a rolling mill to be shaped into the desired form, be it sheets, bars, or coils. The steel is then treated to enhance its properties. This could involve heat treatment to increase hardness or coating it with zinc for corrosion resistance. Finally, the finished steel is ready to be shipped off to where it's needed. Whether it's used to construct skyscrapers, manufacture cars, or create everyday household items, the journey from iron ore to steel is a complex process that requires precision, expertise, and a deep understanding of the properties of metals. So the next time you see a steel structure or a military equipment towering above the cityscape, or use a steel utensil in your kitchen, remember the incredible journey that piece of steel has undertaken. From the depths of the earth as iron ore, to the smelter's furnace, through the steel mill, and finally into your hands.